Okay everyone, so last time we stopped at looking at the Moore model, okay, the 3-segment and the 2-segment style. So you can read through this yourself on the guideline of how to write a good Verilog code to model a state machine. Okay, so here you can see for yourself, but basically using the techniques that we discussed in the previous lectures. Okay, so in this part of the video we are going to look at the Mealy type of FSM. Remember what's the difference between Moore and Mealy? So Mealy, the output depends not only on the present state but also on the input. Okay, in this case we have the input A. Okay, so let's try and write the Verilog code and get the functional block diagram from the ASM chart. Okay, so let's get this up. Okay, so the way I do it, I like to analyze first. So from the ASM chart, we want to know how many states, how many input, and how many output do we have. Okay, so how many states? You can see here we have S0, S1, S2, S3. Okay, so 4 states. 4 states, S0 until S3. How many input? So we have only one input. One input A, one output Z. Okay, and we have a Mealy type output there. Okay, so it helps before you write the Verilog code, you want to derive the FVD first. Okay, that's because it's not so obvious to derive your Verilog code directly from an ASM chart. So you want to get your functional block diagram. So here is your next state logic, output logic, state register, and we have our input A, we have our output Z, 2-bit encoding for our let's call this NS, and here is PS. Okay, and we have our feedback like this. We have a clock and reset, okay, and remember that we also have our A going through like this. Okay, so it's a Mealy type model. Okay, so based on the functional block diagram, we can derive the Verilog code. Okay, so let's see if we can find our block diagram here. So I think this is it. Okay, so let's derive the code. Module FSM2. Let's define our input A, CLK reset, and define our output. Let's call it our output reset. Okay, and then we define our parameter for our 4 states: S0, S1, 1, 2, S3 equals to 3. Okay, 0, 1, 2, 3. And then we define our range. So here is Y. So our state register is exactly the same. Okay, state register is exactly the same. Always at post age of the clock. Again, CLK. Okay, so if we set 0, then we have Y S0, else we have Y big Y. Okay, which is the next state. Okay, let's do our NS logic. Okay, so in the NS logic, it's going to be a little bit different. So you have always at A comma big small y, begin, case y. Okay, so here we're going to look at our ASM chart. Okay, so if our present state is at 0, if A equals to 1, then we have our big Y is equals to S3. You can see here. Okay, so S0, A is 1, you go to S3. Okay. Else, big Y is equals to S0. Okay, so notice that we're not going to take care of the Z yet because we are doing the next state logic. So here I think you can continue yourself. Okay, what happened to S when we are in S1, we check the A, if it stays at S1 or it goes to a different state. Okay, so I'm just going to go straight to our output logic. Okay, so in the output logic we can do something like this: always at A comma Y, begin. Okay, so notice that now we have A and Y together. Okay, because now the output now depends not only on Y but also on A. Okay, so I think we're not going to have room here. Let's do the output logic in a new space. Okay, so here go the output logic. Always at A comma small y, begin, case y. Okay, now when we are in state as 0, what should be our output based on the ASM chart? Okay, so from here, if the state is at 0, then your output Z, okay, will depend on A. So you say that if A, then our Z will be equals to 1, else our Z will be equals to 0. Okay, so you can see there that what we are doing here is we are going to check the state, current state, which is a small y, and also what is our input A. Okay, if our input A is 1, then we're going to set Z, else our Z will be 0. Okay, S1, so you can see S1, if A, okay, so S1, if A, then Z equals to 1, else Z equals to 0, S2, so in S2 there is no Mealy output. Okay, so you can see that if A equals to 1, it goes to state S1. If A equals to 0, it goes back to state S2. So in this case, we can say that Z is simply equals to 0 regardless of what happened to our input A. Okay, S3. So S3 is also the same. Okay, there is no Mealy output in S3. So in S3, it goes straight and it goes straight. Okay, so you say that Z equals to 0. Okay, and case and module. Okay, so that's it. That's basically our Verilog code for the ASM chart. So we have derived the functional plot diagram, and the functional plot diagram will help us, okay, together with the ASM chart, will help us to derive the actual Verilog code. Okay.